Perfect. Okay, cool. So spoiler, you're all going to find out what the unanswerable question is. I've had people reach out to me on Twitter wanting to know the answer before this talk. So we're actually I'm going to reveal the answer. It's really not that impressive. So who am I? I'm Steve Wade. I'm an independent Kubernetes consultant and trainer. I'm currently platform lead at Mettle. I've contributed to a number of different tools. The main one that we're going to talk about in this list is Flux. This talk is quite high level. I've actually documented in quite a lot of blog posts in more detail. So feel free to kind of check them out and reach out to me if you've got any further questions. So what is Mettle? Well, Mettle is a venture inside of RBS, which was set up to provide business banking to our customers. So digital business banking, so no bricks and mortars. You can't go into a Mettle store or a Mettle branch and speak to someone. It's all done via the telephone or the Mettle mobile app. So I want to start with this quote from Kelsey, because I think this really kind of sets the scene nicely. So Kelsey said, once you've found success, your next goal should be helping others to do the same. And what I'm going to do is replace success with a pattern that works. And at Mettle, we found a pattern that works really well for us. And this whole presentation is about the journey that we've been on the last 18 months to 2 years, to explain why we went on that, some of the lessons that we've learned, and hopefully you can kind of take that back to your organization and implement it. One thing you'll note about this slide is I've deliberately missed off the number of retweets and likes I had, because it is embarrassingly pathetic compared to Kelsey's. So we're going to start with, what was this question, this unanswerable question that I got asked very early on at my tenure at Mettle. Then we're going to talk about this mission statement, and the mission statement that we constructed to be able to answer this question and other questions that we were asked. Then we'll dig into a little bit more of the details, so the implementation, and then finally we'll answer the question, can we answer the question now? So when I think of banking, I think a lot of this, right? Guys in suits high-fiving each other when they've made deals. But the real thing that we want to see from a technical standpoint is all of this red tape that gets put in place, right? Slow releases, big bang releases, change approval boards. We've all been there, we've all experienced them. And why Mettle was kind of spun up, I think, was for us to be able to show a new way of working and doing things differently. But because of that, this happened. So imagine this as everybody else within RBS and other areas of the business. They were always intrigued in what we were doing, right? Some of them because they wanted to learn new things, some of them because they were envious. But because of that, this was me trying to explain to them how everything we were doing was okay. We'll figure it out. We know what we're doing. Just trust in us, right? The classic consultant line, everything's going to be all right. So, spoiler, what was the question? The question that I got asked was, how long would it take to rebuild an environment? And I kind of answered with a shrug. And I was like, well, we don't need to rebuild an environment, right? We're leveraging Kubernetes. It does desired state reconciliation. We delete a pod, a new one comes back up. We delete a node, another node comes up. Like, why do we need to bother about this? And then I thought to myself, actually, you've asked me a question that I don't know the answer to, and that doesn't really sit well with me as a professional, right? And the fact that I can't give you an answer, and I'm a consultant that's coming in to help you, it doesn't sit well with me, and we need to be able to get an answer to this question. So we kind of went on this platform rebuild, and we're going to talk about platform V1 and platform V2. So platform V2, what's there now? Platform V1, what was there when I joined? So we took a look at platform V1, and there were a couple of things that kind of stuck out to us that made answering this question very difficult. Some of those were around the ability to be able to perform automation. So we automated some of the infrastructure, but not all of it. To give you an example, the EC2 instances were automated. The DNS was not. Apparently DNS had to be done manually at the time. The way that we onboarded new microservices was very manual. The platform engineering team had to actually execute the first time the application got onboarded onto the cluster, and then every other time after that, the developers could use their CI/CD tooling to be able to deploy that. So what we wanted to do is we wanted to start with a mission statement. And for any of you that are familiar with technology, the more buzzwords you can fit in this mission statement, the more likely the business are to agree that this is a good idea. So we started with this mission statement: to provide an easily recoverable, so if we can recover it, we can answer the question that I couldn't answer earlier. Consistent platform, because that was something that we didn't have in V1. We had a large level of inconsistency because we were doing things manually, and everyone knows when you do things manually, you're going to get inconsistency. And then finally, there was this one around ownership and self-service to developers. So we wanted the right people to be owning the right areas of the platform, and we wanted to allow the developers to be able to innovate and not block them, right? So it was getting the right separation of concerns with regards to teams. So quick story of what the infrastructure looks like. So we run heavily on Amazon. We deploy the Kubernetes cluster on top of that, and then we want to run the Mettle workloads. Simple, right? Relatively trivial. Why are you giving a 30-minute presentation on this? So when we started this replatforming, we had a decision to make, right? Do we push changes into the cluster, or do we pull them? And we thought long and hard about this, and we thought about all of the issues that we were having in the past. So a prime example was for us to be able to deploy a change of an alert in Prometheus, we were deploying the whole Prometheus Helm chart. But as a developer, that's pretty unengaging, right? For them to understand how this Helm chart is constructed. They don't need to understand that. They just need an interface where they can construct things and a way of syncing those changes into the cluster. That's something very, very trivial, like a config of an alert. But if we take that all the way to, changes to the infrastructure or the way a new application gets deployed, if we can pull them in, we are declaring the state that we would like the system to be in out of band of the platform existing, right? So we can stand up and tear down the platform as many times as we want, and we will get back to the desired state that we have in Git. So we went with Flux. Flux was a choice that we decided to go with regards to GitOps tools. The reason why we decided to do that was because the developers had already spent a lot of time constructing concourse pipelines. They're heavy users of concourse, and we essentially wanted to hook GitOps into their existing pipelines. We didn't want them to have to re-implement everything. We were already re-implementing a platform. If we tried to re-implement their whole of their CI/CD pipeline, we would have never got this thing shipped. And the reason why this really spoke to us was, a couple of things. Everything that you see on the bottom right or inside the dashed box is stuff that's running inside Kubernetes. So the long and short of this is you have an agent inside the cluster, which is Flux CD in this perspective. And Flux CD is going to do this kind of two-directional sync. So it's going to sync with a Git repository or a number of Git repositories. And then it's going to have this way of being able to poll for new images. So when we think about new images, think about releasing new versions of microservices. And what we've done is we've stopped people being able to do kubectl apply, so on the bottom left there, to reduce the privileges down that people need to be able to make changes to the cluster. So if we drive everything through with Git, we get a nice auditability perspective. We get better controls over who can do what to what environment. And just generally, we have a way of being able to understand the source of truth of the platform, right? If we allow people to be able to manually apply changes via kubectl or tweak or change the structure of the platform, they will not be stored anywhere. Well, they may be stored in people's laptops in their history, but we're never going to be able to resurrect the platform back to what it looked like before. So if we can set Flux up right and we can get this syncing, we're going to be able to get the easily recoverable, right? We're going to stand up the cluster and all these fluxes are going to reconcile and we'll get back to where we were. But the consistency piece is the really important piece, right? How do we get cookie cutter environments? We've got a number of environments that we have now. As everybody knows, developers love new environments because they want to test out a new thing, or platform engineering want to, be able to run stress tests or, practice migrations. So we need a way of being able to cookie cutter these environments. So the way we do that is with this kind of 3-character environment prefix, and that flows all the way through the whole infrastructure, all of the applications, everything. So we do that within DNS. We do that, and that flows through all of our GitOps repositories. And then finally in our microservice image tags. And I'm going to kind of gloss over that very quickly because we're going to get onto that a bit later. So now with regards to clear ownership. So the way that we're going to get clear ownership is we're going to have separate repositories with different code owners. So different code owners, people that are able to approve PRs that make specific or different types of changes to the whole entire platform. So how are the repositories structured? So before we kind of go into that, I want to quickly talk about the Helm operator. So we had previously in Platform V1, all of the microservices were deployed using Helm. All of the application repositories had their own unique Helm charts. As you can imagine, a lot of inconsistency. Developers love to copy and paste. All engineers love to do that. But not everybody is a Kubernetes expert, and nor should they have to be, right? But they don't know what they're copying and pasting. So there was a lot of inconsistency, and there was a lot of understanding and burden that were put on developers, and we wanted to remove that from them and provide them with an interface to onboard new applications. So before Concourse was pushing changes in to the Kubernetes clusters using Helm, what the Helm operator does is it's another agent that sits inside the cluster. And its job is to reconcile what we call custom Helm resources or Helm releases. So rather than us having a plethora of Helm charts, we now have a single back-end Helm chart, and we are going to instantiate a number of Helm releases, and that will be the way that developers now onboard new microservices into the cluster. So what is a Helm release? So a Helm release essentially looks a little bit like this. It's a YAML file. If you're familiar with Kubernetes, you're going to have to become very familiar with YAML. That's all everybody talks about. So a Helm release has a release name, and that release name needs to be unique in the whole entire cluster. Then it has a chart, and you provide it with a location for that chart, whether that be a chart repository, whether that be a GitHub URL or a GitHub link. And then the name of the chart and the version that you want to deploy. And then underneath that sits all the values that you want to specify. So very similar to values.yaml if you're familiar with a Helm chart, but now we're doing it in a single location rather than a Helm chart per microservice. And then one of the great things about Helm releases is it provides us with these annotations. So these two annotations here are saying, I'm going to allow you to do automatic image updates, and I'm going to allow you to perform them against the image that I've specified where it matches this semantic version. So if we deployed or created a new container image of pod info at 3.0.1, Flux would go and see that, and Flux would deploy 3.0.1 for us. So we don't have to make changes to the cluster. Flux is going to do this for us. Remember that kind of bidirectional sync of image tags. This is going to become very prevalent of how we deploy changes through environments. So the way all this works is that we start with a repository called kubernetes-resources, and kubernetes-resources is where the vanilla or bare bones of the cluster comes up. So replace kind of Kubernetes-resources with cluster bootstrapping / platform engineering workloads. So in here we've got things like Prometheus, we've got Kibana, we've got Grafana, but we've also got all of the role-based access control policies to allow developers and engineers to be able to interact with the Kubernetes cluster the way that we would like them to interact with it. So we're heavy users of Kustomize at Mettle. So within Kustomize, we have a modules directory. So for any of you that are not familiar with Kustomize, you essentially have a base, and then you have a set of patches or overlays, and that's what takes your kind of vanilla templatized YAML files and turns them into, say, specific versions that you want to apply to dev, or another version that you want to apply to staging. So our underscore modules directory is all of the YAML files, whether those be normal manifests or whether those be Helm releases, but they do not include environment-specific configuration. because those are going to be supplied at the environment specific directories. So dev for development, PRD for production. So inside modules, we have a number of different options that we can choose. I like to think of this as kind of a pick-a-mix or an a la carte menu. Not all of these directories have to be deployed to every environment. There's some obvious ones here that will, an example, cluster, but things like docs, we have a tools environment, that's where our documentation lives. So I want to kind of talk about Istio here as an example. So we have an Istio directory. And then inside the dev directory, we also have the same Istio directory, but here is where we specify the dev overlays. So the environment that we're going to point at, and also the URLs for us to be able to talk to Prometheus. So we've got a way now, and we've got a pattern to construct Helm releases for us to be able to deploy changes or workloads to a platform. But there's always this difficult question, right? How do you handle secrets, right? Do you get the app to do it, or how do you deploy these and manage these inside your platform? For us, we use sealed secrets, and Flux plus sealed secrets is pretty awesome. So for any of you that are not familiar with Bitnami sealed secrets, kind of concept works that, again, you have another agent inside the cluster, which has the private key. You seal your secrets with a public key. You can put those in Git because the only thing that can read them is the cluster that is running that has the corresponding private key. And then we have a dedicated Flux instance, which essentially reconciles these sealed secrets. The sealed secrets controller picks them up, turns them into normal Kubernetes secrets, and away we go. We're at the races. So we have all of our secrets declared in Git. Very similar kind of structure here. We have a sealed secrets directory, and then within that sealed secrets directory, again, the 3-letter environment prefix. So you can see here that it's flowing through all the repositories that we use within Mettle. Then coming on to the crux of it. So we've got a way of deploying secrets. We've got a way of deploying different types of workloads or cluster level workloads or platform workloads into the system. But how do we actually deploy Mettle workloads into the system? So we moved to customize inside platform engineering in the Kubernetes resources repository, because we wanted to cut ourselves and learn all of the lessons and make all of the mistakes before we kind of got the developers to embrace this as a kind of pattern. So you'll see here that they are leveraging customize again, but their directory looks a little bit different. So base is their non-environment specific configuration, and then they just have the 3-letter environment prefixes for the environments that they want to deploy to. We called tools because if we shorten it to TLS, it's going to get very confusing when we're having different types of conversations. So the base directory, as we've kind of alluded to, is this non-environment specific configuration. So again, it's that a la carte menu, that pick a mix, which allows them to pick and choose what products get deployed to specific clusters. So let's take the account balance microservice or Helm release here at the base level. So you'll see here a couple of things. It's pointing to the backend chart. So we've constructed a backend chart which all microservices use, and we have a small set of tweaks to those backend charts. So we have another one that's kind of a generic chart, and then another backend chart that is from Micronaut. Whole idea being all of the kind of best practices are already in here: consistent labeling taxonomy, consistent naming taxonomy, horizontal pod autoscaler, all of the things that you should be doing, but we've got them in one location. The thing that you'll notice here is that we don't have the chart version. And the reason for that is that the chart version is specific to the environment or the cluster that we are deploying into. So for any of you remember the Kubernetes 1.16 release, they deprecated a load of APIs. So for everything that was running on a cluster that was pre-116. The chart version was 1.x. Then when we migrated to Kubernetes 1.16, we changed the chart version to 2.x. And then for us to know whether your microservice is able to run in Kubernetes 1.16, we changed all of the versions in that environment to 2.x, and then Flux did the rest for us. The final thing here that you'll notice is that we don't have an image tag, and that's because, again, the image tag is specific to the environment that we're deploying in. Then if we have a look at the environment-specific directories, they again look very similar to base, but here is where we start to overlay environment-specific configuration. So in dev, we're going to tell Flux that for this Helm release, we want you to look for new images that have the tag dev-star. We'll provide it with an image tag to start with, and then finally we'll specify the chart version that we want to deploy here. So you can see from here that we've got the dev directory and it's looking at a dev glob, and we've got a dev tag. Doesn't really take a rocket scientist to work out what staging in production is going to look like, right? We want to keep the cognitive load down and make it simple for developers to onboard applications. What you'll also notice here in this dev directory is this Flux patch. So when I was saying before that Flux goes to the registry and looks for new images, it also deploys them, and then once it's deployed them, it writes the change back to Git. So we've got now a history of all of the changes or all of the versions of microservices that have been deployed to all environments in a single repository. So this makes auditing easier. It's making, our ability to be able to diagnose problems easier. If we had a problem with the cluster at 4 p.m., we go to this repository, what kind of things got deployed to that environment around, 3:45 to 4. We've got a way of being able to see changes now. Pretty awesome, right? So now how do we actually perform continuous delivery? So congratulations, Steve, you and the team have constructed a load of repositories and you've got Flux syncing them. Brilliant. But how do you actually make changes, right? That's what everybody needs to know. So we'll start with microservice pipelines. So Mettle workloads, custom workloads here. How do we make changes to them? So as I alluded to before, we have our repositories in GitHub, and they are heavy users of Concourse. So they perform a Docker build. I've deliberately skipped out a load of steps here. I'm trying to keep this relatively simple. With a tag of dev-commit char. They use the long commit char here. We push that up to our registry, or our image registry, sorry, GCR, with this new tag. So the new tag is sitting there in the image registry, and Flux is also sitting inside the cluster and is looking for new image tags. Once it eventually finds one, it patches the Helm release. So the Helm release locally to the Flux pod. Runs a kubectl apply, essentially applies the changes to the cluster, and then commits the changes back to Git. In the meantime, Concourse is sitting there, and we wrote a little script that's waiting for the update. So because we've got this consistent labeling taxonomy, we have a way now of being able to target specific microservices at specific versions. And because one of the tags we have is app version, and the app version value is the value of the image tag, we have a way of being able to ask Kubernetes whether my microservice version has been deployed. Then they perform some testing, and then to go to staging, they push another or re-tag the Docker image with a new image tag of stage or stooge, and then they just test, rinse, and repeat. And the value behind this now is that we have got the developers doing the things that developers want to be doing or thinking about or caring about, which is, how do I gain confidence to move between environments? They don't care how this thing gets deployed. They don't want to know about Kubernetes. They don't need to understand the difference between a deployment and a replica set. We want developers to bring value to our customers, right? That's the main thing. All of this other stuff is tooling that enables that to happen, but also gives us the consistency. So that's microservice versions, but what about Kubernetes manifests? So, you know, how do you handle API deprecations? So here we use Circle CI because we don't need to use concourse. We don't have any feature tests that are specifically running against these. So the first thing that we do is reuse conf test. So what conf test does is allows us to be able to construct rego policies. So essentially policies that can check YAML. And all we are doing here is checking for deprecated APIs. So if you think about this, we have this running in our Helm charts repo, making sure that we're not using any deprecated API versions. So we're checking against 120 when we're running a cluster of 117. And the reason why we do that is because we want to have relatively strong confidence that when we upgrade the Kubernetes cluster, the same manifests and the same Helm release versions can get deployed successfully. Don't ask me about the 114 to 116. It was a little bit of a mess, and this tool helped us greatly. The next one that we run is kubeval, and what kubeval does is validates the YAML against the upstream JSON schema. So shout out to Gareth Rushgrove for creating this. We run it in strict mode, and that just makes sure and gives us confidence that the YAML that we're trying to deploy matches the YAML that the API is expecting, and we're not adding new fields. And then the final one is HRval. So Stefan Prodan wrote this tool, and what this tool does is takes your Helm release, so the Helm release, you know, the Flux manifest essentially, downloads the chart at the version that you've specified, runs a Helm template using the default values plus the values that you've specified in your Helm release, and then runs kubeval against them. But what Dan Volk did in our team, shout outs to Dan for this, he actually went a bit further. So we customized this slightly, and we now run kubeval and all of our conf tests against our Helm releases. So what this is doing is it's just giving us more confidence that by the time it hits Kubernetes, it should apply, and the issues that we have are going to be application issues rather than misconfiguration. So how does the kind of cluster come up? So we deploy on Amazon Kubernetes. We use Bootkube for this. The first repository that comes up is kubernetes-resources, because that's going to do the bare bones workloads and configuration. The way that we do that is we point that at a directory. So if we're standing up the dev cluster, we're going to point at the dev directory within inside of that repository. For any of you that were eagle-eyed, you would have noticed a directory in this modules directory, which is a Flux directory. And what this Flux directory is a load of other Fluxes that we need to stand up different or deploy different resources to our platform. So the Bootstrap one, Bootstrap directory here is the first Flux that we have that we install. We actually overwrite it. So Flux can upgrade Flux. Mind's blown. So when Kubernetes resources comes up, we deploy another Flux for Kubernetes releases Mettle. That's going to deploy the Mettle workloads, secrets for secrets, Kafka topics, because we're heavy users of Kafka. Right, it's getting a little bit boring now, but you kind of get the story. Calico for network resources, Istio for Istio resources, and they all point at some directory / this environment prefix, right? And now we have a consistent way of deploying manifests or workloads to our platform. So, $1,000,000 question, can we answer the question now? Yes, thankfully we can. It takes us around 25, 27, 30 minutes to do a full teardown of the Kubernetes cluster and to reconcile back to exactly where we were before. If you asked me that question 18 months to 2 years ago, I would just say unknown or unlimited. I had no way of knowing that. And we've actually recorded this and actually kind of shown this in practice. So in the last 18 months to 2 years, we've successfully completed our mission of being able to tell RBS how long it would take us to rebuild a cluster. So I'm going to leave these links on the screen for a couple of seconds if you want to take screenshots or whatever. So top half is some of the tooling that we use at Mettle, and bottom half is an example of the deprecation policies that we write. A very, very simple repo for doing GitOps with Customize, and then finally the Medium blog posts, which go into a lot more technical detail about how all this stuff works under the covers. And with that, I'm done. Happy to take any questions.
Thanks, Steve. That was wonderful.
No problem.
Do send me your presentation, because obviously we'll be circulating it with all attendees tomorrow, and then they will have constant access to all of those links that you've just shared. There's quite a few questions. There's 4.
Okay.
So I don't know if you just want to stay on and answer these. So we'll ask one now, for example, is any tools you use to detect compliance violations on KAS Mettle?
From a compliance perspective, we kind of are leveraging Conftest. So Rego policies at the PR level. We could also have Open Policy Agent running inside the Kubernetes cluster to do that kind of final check. But changes can't make their way to inside the cluster without going through the PR approval process. So we have a lot of linting and a lot of CI at that level, which stops kind of uncompliant changes, if you'd like to call them that, made to the cluster. The other tooling that we use is a tool from Fairwinds called Polaris. If you're familiar with Polaris, essentially it gives you a score of all of your deployments, and it's looking for things like root file system, running as root, too many privileges, and we use that to kind of gauge how secure our kind of platform is. And that's kind of an iterative process, because the more workloads that we deploy, you know, the more changes potentially that we have to make. But that's a good kind of starting point.
Okay, someone else has asked, how are developers able to interact with the cluster to, as an example, check a specific deployment or current configuration for a service? Are they using tools and not kube control? Are there any other repositories?
So to answer your kind of question around configuration, so configuration is all driven from the Helm release. So you can provide a config map or a number of config maps, and that's all configurable within your Helm release. Or you can specify that you want to use environment variables and send it to a Kubernetes secret if you deploy that way. For them to be able to see what's going on with inside the cluster. In all clusters, developers get read-only. They don't get read-only necessarily to all resources, but they get read-only to the resources that they care about. So yes, they can see deployments. Yes, they can see pods. Yes, they can see nodes. They can't see secrets in all environments for obvious reasons. But they have the tooling there. We've just scoped it in such a way that you can't run kubectl apply. So you can't add or manipulate. You can only look and view. And we do all that with role-based access control.